So you can see I have all my absorbances there in the final column. You will have to determine the concentrations and the dilutions. That is going to be your job. If you take a look in the lab manual, there are instructions on how to do so if you're not sure how to do these kind of calculations. You can always contact me if you have any questions. So what we're going to do with this data is we're going to make a plot which is called a standard curve. So to make a standard curve, what we need to do is plot absorbance and concentration on a graph. By the way, you can make your graph on graph paper, or you can use a computer software package. If you do choose to use software and you're interested in using Microsoft Excel, I'm going to have a small Excel tutorial at the end of this video that will hopefully help you to get started. So take a look at that, and you can always contact me if you have any questions about Microsoft Excel. So we're going to plot absorbance on the y-axis. So there's absorbance. Absorbance does not have actual any units, but you do need to indicate what wavelength the absorbance was measured at. So that would be 525 nanometers. Concentration is on the x-axis, and the units are micromoles per liter. Notice that's a big M for moles per liter. So plot the data. There is the data right there, and make sure you use big visible symbols. Don't use little dots or something that are hard to see. I want to see all the data points nice, clear, and visible. Then what you're going to do is add a trend line. So a trend line is not connecting the dots. A trend line is a line of best fit, so the whole thing is straight. You can use a ruler on graph paper, or there are ways to do this on Excel. And the nice thing about Excel is Excel will actually give you the equation of the line. So y equals mx plus b. There is no b because the intercept is 0, 0. So y equals mx, therefore the slope in this case is 0.05x. So take note that this plot can be used later, and that's why we're generating this plot. We're going to use it later in part C and D, and we're going to use that to determine our concentrations. So in part C and D, we're damaging the membranes using temperature and solvents, and we're going to measure an absorbance. And from that absorbance, because we don't know the concentration, we're going to determine the concentration. I'll show you basically how this works. Now, the relationship between absorbance and concentration is called Beer's law, or the Beer-Lambert law. This is named after a couple of scientists who initially investigated this. So if you take a look, there's a formula. Absorbance is equal to epsilon B C. So C is concentration. So what is B? B is actually the width of the cuvette. The cuvette is the little square test tube-like thing that the sample is in, and those are standardized to be 1 centimeter. And epsilon is a constant. So what it's saying is that A is directly proportional to C, the concentration, under given conditions for a given pigment. So more on this later after we complete parts B, C, and D. We're going to come back to this graph and show you how to determine concentration when you have an absorbance value. So here's our data from the temperature tests and the solvent tests. So you may notice that we still have not figured out what the concentration is of our Betacyanin leaked in each of these different conditions. So remember, I told you earlier that what we need to do is figure out these concentrations using our standard curves. So I'm going to show you how to do that right now. So in order to determine our concentration using the standard curve, we can either plot the data on the curve or we can use the equation of the line. I will show you how to do both methods right now. So here's an example. We have a sample and the absorbance is 0.25. So what you can do is basically plot that on the graph. So 0.25 is right about here. And you can see I've plotted it over to my trend line. And then basically, in order to find out the concentration, I can draw a vertical line down to the concentration. So in this example here, the concentration is about 5 micromoles per liter. So that's one way to do it. This is maybe a little less accurate than using the equation of the line, and I will show you how to do that right now. So to use the equation of the line, I'm just using that y equals 0.05x. So in this particular example, absorbance, of course, is y, and x is concentration. So I can manipulate that formula and turn it around so that concentration is absorbance divided by 0.05. So in this case, that's 0.25 divided by 0.05, and therefore my concentration is 5 micromoles per liter. So you can use either method. Like I said, if you have the equation on the line, it's pretty easy to punch that in, And do make sure you do provide me with a sample calculation for your lab report. So here we are back to our tables. I'm not going to give you the values for concentrations. That's something that you are going to have to do yourself. But once you get your concentrations, you're going to produce some graphs for me. So I'll show you how to make those graphs. For your temperature stress test, you are going to make a graph, and it is going to have temperature on the x-axis, concentration on the y-axis. So let's add some data points. I'll make a little graph here for you. So minus 20, some of the other temperatures are going to all have data points. And so for this graph, what you're going to do is basically connect the dots. You can do a straight line or you can do a curved line like what I just did there. There are different ways to do it on the computer, but what you're going to see is a trend. Now, this is not the trend that you're going to see. You're going to see a different trend. I will leave that as a surprise for you. But what I do want to do is give you some graphing tips. First graphing tip, use clearly defined data points. So you can see what I did is I had some nice circles as my data points. They don't have to be shaded in, you can have them open. You can use squares, you can use triangles, stars, and so on. Just make sure your data points are really clearly defined, that you're not using the little teeny tiny ones that are hard to see. I want to be able to see every data point very clearly. Number 2, include the proper units. So you can see that I have degrees Celsius for temperature and micromoles per liter for concentration. Make sure you have the accurate units or else temperature is meaningless. This could be Fahrenheit or Kelvin or anything like that. Number 3, put a title below the graph. So in Biology 107, a graph or a figure are the same thing. They're all called figures, and figures have the titles below. A table is a different thing. A table has a figure above it. So a figure title is below, and that figure title is going to have a number. So that's the next point. And so that number is going to be, if you have 3 graphs, they're going to be 1, 2, 3. Or in this case, it's lab 3, so I've named them figure 3-1, 3-2, 3-3. So make sure you have a system and they're numbered and it makes sense. Secondly, make sure that the title is descriptive. So this particular experiment is involving membranes and beats and temperature and betacyanin. So all those words should be in your title. Give me a description of what the experiment was about. If you can't do it in 1 sentence, do it in 2 sentences. It's not really a big deal. Do make sure that you include the species that we were researching. So in this case here, it was a beetroot, but you want to use the scientific binomial name, and that of course is going to be in italics. For the solvent test, you're going to make another graph, and this graph is going to have solvent on the x-axis and concentration on the y-axis. So this graph is going to be a bar graph. So I'll make some bars here. Here's the water. Going to shade that in to make it a little bit easier to see the bar. Here's the methanol. And you're going to make yours look a lot prettier than this. Maybe use a ruler if you're doing this by hand because we want to have a nice and tidy graphs. So same thing here. You're going to see a trend that you're going to be able to describe. This is not the trend that you are going to see. But you're going to make a nice graph and you're going to see a nice trend and you're going to be able to discuss that in your lab report. So for your lab report, you're going to have 3 graphs. The first one is going to be the standard curve. The second one is going to be the temperature test. The third one is going to be a solvent test. All of them are going to be beautiful and you're going to get lots of marks in your lab report. So let's talk about how we can make graphs in Microsoft Excel. So here's Microsoft Excel. You can see I have some data there, some concentration and absorbance data. This is not our data. This is from another experiment, but we can do the same thing to produce a graph. So what you need to do is basically select the data. And so what you can do is bring your mouse over here and highlight all of that data in both columns, concentration and absorbance. Then you're going to go over here to insert, the insert ribbon. You're going to go over and you can see there's these different graph types over here. You're going to select scatter graph. And this is the one I like the best. And this way it doesn't draw the lines because I'm going to draw the trend line afterwards. So I'm going to select that. So first we need to just fix this up a little bit. Notice there's a title up at the top. We don't want titles at the top in Biology 107, so I'm just going to click on this and then hit delete to remove that. So you can put your title down at the bottom if you like. So figure 3-1, Give it a descriptive title. Or you can put the title in Microsoft Word after you're done inserting the graph as well. So notice it does not have any labels on the axes. So what you can do is click on the graph itself. And if you take a look, now this has made an extra section up at top. So we have chart design and format. I want chart design. And over here on the left, you can see add chart element. So over here, axes titles. And I'm going to add a horizontal axis title. So there it is. So remember, my horizontal title is concentration, and my units are micromoles per liter. And so to get that micro, I'm going to go up here to insert, and somewhere there should be a symbol. It's over here on the right, and you can see symbol. So what I need to do now is find the micro in here. So I'm sure it's in here somewhere. I just have to see if I can find it. Scroll down a little bit. It's probably here somewhere. Where is it? Oh, it looks like it's one of my recently used symbols. So I'll just grab it there. And I hit insert and close, and there is my special symbol. So if I'm not happy with the font size on this thing, I can select the entire graph and I can just increase the font size on everything. That looks a little bit better already. So I need to add the horizontal title, so chart design again, add chart element, axis title, and vertical. So my vertical title is, of course, absorbance. Type that in, and we got 525 nanometers. There we go. So you can adjust these things, move them around a little bit. If you don't like the size of your graph, you can always resize it and so on. And there we go. So something you can see that automatically gives me some nice symbols. If you don't like these symbols, there are ways to fix them. I think this is under format. Or if I double click on it and go over to the right, there are some options here for my series symbols and series options. So I can click on this and right here. So the marker and marker options. So in this case here, let's see here. I'm going to maybe make it a different shape. I'll make it a triangle. And let's see here, maybe I want a different color. What color do we like? Maybe I'm out of blue ink, so I will choose, let's say, red ink. And if you don't like the size, you can increase the size. So there we go. Okay, so there's my graph. And I mentioned before that one thing that I like to do is add a trend line. And that way I can get the equation of the line as well. So what I do is I double click on this, or sorry, no, I don't double click. I right click on this. And once I'm on the data, as you can see down here, it says add trend line. So I click on add trend line. And if I scroll down here, you can see I can put display equation on the chart. So there's my equation right here. And so you can see y equals mx plus b is y equals 0.621x minus 0.002. So something you can do for this graph is with that trend line, so let me just go back to the trend line menu here, is I can also set the intercept to 0, 0, because of course the graph does go through 0, 0. So what this does is corrects the line a little bit, gives me a slightly different slope, but it removes any issues I have with some really, really small numbers. So I can do that, it removes the intercept, and I just have y equals mx, which is 0.0619x. So that's how to make a graph. If you want to make a bar graph, you could do something similar, except for when you select the graph type, you're going to select bar graph. So play around with it a little bit, and hopefully you can make some nice graphs for this report.